So I got cut off right there before I gave you the answer. So if we subtract those two values, bigger minus smaller, you can see that the mouse was faster by 0.93 seconds. That's letter A. All right, so let's go ahead and go on to number 37. So 37, we're going to use this scenario for the next 4 questions. The manager of a local soft drink bottling company believes that the new beverage dispensing machine is set to dispense 7 ounces. It in fact dispenses an amount X at random with a value anywhere between 6 and 8 ounces inclusive. So suppose X has a uniform probability distribution. Remember that a uniform probability distribution is going to be a rectangle. It's flat across. So that is another continuous distribution, but instead of being a normal curve, it's a rectangle. Let's see, it goes anywhere between 6 and 8 ounces. Remember that you can find that height because the area underneath the whole curve is always 1, right there. Underneath the whole curve is 1 or 100%. So if you consider this as area equals base times height, well, I know the area underneath the whole curve is 1, the length of the base is 2, then times the height. So to find the height, you just divide by 2. So remember, the way that we taught this in class is that the height of the rectangle is always 1 divided by the length of the rectangle. Okay, but the first question they ask us is what is the mean and standard deviation for the distribution? So remember, the mean is just the average between the endpoints. So A plus B, so 6 plus 8 divided by 2, and that's how you get 7. So give rid of letter C there. The standard deviation is actually a formula that will be given to you. It's the square root of the upper endpoint, so B, minus the lower endpoint of 6. Then we're going to square that and divide by 12. So remember, the standard deviation for uniform is square root of B minus A squared divided by 12. And that is given to you on your formula chart. So the square root of 8 minus, use parentheses here, 8 minus 6 squared divided by 12, and that's how I get 0.577. So it's got to be letter D. Number 38, what is the probability? So now we're finding the probability that for a randomly selected bottle, the machine will dispense more than 6.5 ounces. So I want X to be more than 6.5. So essentially I'm going up to this curve, and if I want more than 6.5, it'd be 6.5 and higher, but there is a max. I need you guys to realize this. This curve does not go to infinity and negative infinity like normal curves do. So since there's a max, you're going to find the length between 8 and 6.5 and then multiply that by the height. Because remember, to find the probability underneath the curve, you just find the area underneath the curve. And since it's a rectangle, it's just base times height. So you find the length for the new base times the height. So if I type that in, I get 0.75. What's the probability? So another probability problem that for a randomly selected bottle, the machine will dispense at least 6.5 ounces. Remember, at least means greater than or equal to 6.5. Well, remember, in a continuous distribution, you can't equal a set value. If it's at a set value, the probability of that happening is 0. So me saying greater than 6.5 and me saying greater than or equal to 6.5 is not going to change anything. Okay, the only time that changes is if you're a discrete distribution, like the binom PDF and CDF stuff, that matters. But for continuous distribution, so that's uniform and normal curves, it doesn't matter whether you include the value or not. Okay, and then last one for that, what is the probability that for a randomly selected bottle, so find the probability, the amount of soda the machine will dispense is within 1 standard deviation of the mean. So that means I'm going to do the mean plus or minus 1 standard deviation. So if I do the mean plus or minus 1 standard deviation, well, let's see, the mean was 7. I'm just getting this from 37. So it'd be 7 plus or minus 1 standard deviation, which is 0.577. So if I subtract 0.577 from 7, I would get 6.423. Then 2 If I add 0.577, I get 7.577. So I'm really finding the probability that we're in between these two values. So once again, just like up in number 38, I'm going to find the length between those two values, which technically is just multiplying 2 times the standard deviation, and then times the height. So I get 0.577. So that's uniform. Looks like we have another uniform example. So the next one we're going to use for the next 3 questions. High temperatures in Dallas in March have a uniform distribution. So that means I'm going to have my nice little rectangle here. This time they give me a mean of 82. So remember, the mean is right in the middle of a continuous distribution, and the range is 8. So I know the entire rectangle takes a distance of 8. So think about this logically. If 82 is in the middle and you have to cover 8 total, you're going to go 4 up and 4 down. So 4 up and 4 down. So 4 up would be 86, 4 down would be 78, and my height is 1 divided by the entire length, which is 8. So that's what our curve looks like. So now they want to know what's the probability that a temperature will be above 80. So x is greater than 80. So once again, I need you guys to realize these curves have maxes and mins. They do not go on forever. So if I want above 80, I want 80 to 86, which means I would do 86 minus 80 and multiply by the height of 1/8. And that's how I get 0.75. Okay, what is the probability that the temperature will be between 80 and 84? So if I want to be between 80 and 84, I would find the length between those two values and then multiply by the height. So that's going to be 0.5. And then what's the temperature at the 75th percentile? Remember, 75th percentile means 75% at or below. Okay, so I want to find 75% of the data is at or below what value. So this I actually kind of have to go backwards. Remember that percentages are the same things as probabilities. So I know that the probability of a value, so the probability that x is less than something, is 0.75. So I need to find that something. So I'm going to go ahead and go do this the long way. So it's 0.75 equals some value, let's just say it's here, right? Some value x minus, because it's at or below that value, so x minus 78, then times the height of 1/8. So I'm trying to find what value minus 78 times 1/8 gives me 0.75. So I'm going to multiply both sides by 8. So let's see, 0.75 times 8 is 6. Then I have x minus 78 still. So then add 78 to both sides. And that's how I get 84 degrees. And the nice thing about that being multiple choice, guys, you could technically have worked backwards. I could have just done 86 minus 78 times 1/8. 82 minus 78 times 1/8, 84 minus 78 times 1/8, and 88 minus 78 times 1/8, and seen which one gave me 0.75. But you had to know that 0.75 is at or below because they said percentile. Okay. So since the next set of questions go together, I'm going to go ahead and stop there because there's only some seconds left before the next video starts anyways. So we'll pick up with number 44 in the next video.